So my name is Eva Czirr. I'm an Alzheimer's researcher with a PhD in neuroscience. And I've gotten involved in Alzheimer's disease research almost 10 years ago. And at the time, I came from a basic research background, and I was really interested in doing something that is more translational and something that, might eventually help people find a cure for Alzheimer's disease. And unfortunately, around the same time, I actually learned that my grandmother was diagnosed with Alzheimer's disease, and she passed away 3 years ago. And it was very hard to see this in my family, and especially what it did to my mother and to her siblings and how difficult it was. And this actually gave me much more motivation to work on this and really to move into a very translational area of the research. I'm still working in relatively basic research, working in animal models of the disease, but I'm trying to find new avenues for treatment options. And we're focusing especially on inflammation in Alzheimer's disease, which has, especially in recent years, gotten a lot of interest because genome-wide association studies have found immune-related proteins associated with a higher incidence of late-onset Alzheimer's disease. So if you have these variants of these genes, you have a higher chance of developing Alzheimer's. And this has given us a lot of push forward to involve to work on immune-related proteins in Alzheimer's disease. And I'm working on one of the immune-related proteins, which is expressed on an immune cell that is present in the brain. And we found that this receptor is important for clearing away some of this extracellular peptide, the A-beta peptide, that is accumulating in the Alzheimer's disease brain and that we think is one of the causing agents of the disease. And what I found is that not only is this receptor involved in the clearance of this protein once it is present in the brain as deposits, but even when it is in its soluble form. And furthermore, we found a small molecule that can target this receptor and enhance this clearance. So this actually gives us a therapeutic angle on these findings, and we found that at least in mouse models we can reduce the amount of this toxic peptide in the brain when we treat them with this compound. I think especially in the last few years, the Alzheimer's research field has made huge leaps forward. Especially with these genome-wide association studies, we have all these novel candidates that might be important for developing therapeutics in Alzheimer's disease. All these genes and variants of genes that are associated with a higher incidence of having Alzheimer's disease later in life. And we all know about what the public health hazard this disease is, and how I think everyone has someone in their family or knows someone who's suffering from Alzheimer's disease, and yet we have absolutely no cure for this. And I think this is one of the main driving forces behind all of us who are working in this, because we really want to find something that at least slows down the disease, or maybe we can actually find a cure and stop the disease from progressing in patients who are already suffering. So I was lucky enough to win the Young Researchers Award here from the Alzheimer's Association, and this is a personal prize as well as $500 towards travel for a conference. And this is actually very important because you need to travel into these conferences to exchange ideas with other researchers, and a lot of these conferences are pretty expensive, so it's not like you can just get in your car and go out there. So I'm definitely going to use this to either go to the Alzheimer's and Parkinson's conference next year, or the neuroscience conference this fall in Washington, D.C., where there's going to be a lot of Alzheimer's researchers presenting.